Hello there. My name remains Oladapo, and I welcome you to the Global Tutor virtual class. In this video class, I want to continue from where I stopped in my last video class, where I was showing you how to write the electronic configuration using the SPDF. I did a lot of explanation in the last class, so I'll pick it up from there in this class. I remember we wrote the electronic configuration of the first 10 elements, and I dropped an assignment with you to write the electronic configuration of element number 11 to 20. If you have done that, that is very good. But let's continue in this video class. Now, the first thing I want us to look at in this video class, before writing the electronic configuration of elements number 11 to 20, is what we call overlapping of orbital. How does orbital overlap? I will show you in this video. In the first shell, we only have one S. In the second shell, we have two S and we have 2P. In the third shell, we have 3S, we have 3P, and then we have 3D. In the fourth shell, we have 4S, we have 4P, we have 4D, we have 4F. In the fifth shell, we have 5X, we have 5P, we have 5D, we have 5F. Now, these are the orbitals. Now, how do they overlap? Now, these are how they overlap. I know many of you have seen this in your textbook, but you don't know how to interpret it. So let's go now. Let's go now. We have this. Just draw a line, then put an arrow. Draw a line, put an arrow. Draw a line, then put an arrow. Draw a line, then put an arrow. Draw a line, then put an arrow. Now, besides this method, you have other methods, but this is the one that is for your level. So how does orbital overlap now? It means you're going to fill electron into 1s. Then there is no other orbital. You fill 2x. Then after 2x, you will see there is no orbital. You fill 2p. You fill 2p. After 2p, you will see the next thing there is what? Is 3x. So you fill 3s. After 3x, you see there is nothing. You go to the next one, that is this one. You fill 3p. After 3p, you will see the next orbital is this. You fill 4s. After 4s, you fill 3d. So see now, this has shown us that you fill electron into 4x before you fill 3d. Why is it so? Because the energy level in 4s is lower compared to the energy level in 3d. So after 3d, you fill 4p. After 4p, you fill 5s. So let us stop there for this class. Now, what does it mean? You fill electron into 1x, you fill into 2x, you fill into 2p, you fill into 3x, you fill into 3p, you fill into 4s, then you fill into 3d. So let's now see how that applies in writing the electronic configuration of number 11 to 20. Element number 11 will be sodium. So the electronic configuration will be 1s2, 2s2, 2p6, 3s1. You have few electron into the third shell, but now you are putting it into x orbital. Then after sodium, the next we have is magnesium. So the electronic configuration would be 1s2, 2s2, 2p6, 3x2. By the time you feel 3x2, x is occupied. So the next electron is going into a new orbital, that is aluminium. So you have 1s2, 2s2, 2p6, 3s2, 3p1. So you are now in p orbital, in what? In third shell. So the next one after aluminium, you have silicon. The electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p2. Then after silicon, we have phosphorus. That would be 1s2, 2s2, 2p6, 3x2, 3p3. So you are still filling electron into the p orbital. So after that, what do we have? We have sulfur. So the electronic configuration would be 1s2, would be 2s2, would be 2p6, would be 3x2, will be 3p4. Then the next one would be chlorine. The next one will be chlorine. That will be 1s2, 2s2, 2p6, 3x2, 3p5. So the next one is going to be what? Argon. And that will be 1s2, 2s2, 2p6, 3s2, 3p6. By the time we fill the sixth electron into p orbital, then p is filled. Now, from what we did above here, it shows that immediately we fill p orbital, the next orbital we are filling is 4s. The moment we fill 3p, the next orbital we're filling is 4s. So let's go. It means the next element, potassium, would have 1s2, 2s2, 2p6, 3s2, 3p6, then 4s1. Then the last for that's number 20 would be calcium. That would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. By the time we fill 4s2, the next orbital to be filled, if you go to the overlapping of orbital, the next orbital to be filled would be 3d. The next orbital we need to fill will be 3d. Meaning, if you are writing the electronic configuration of elements 21 to 30, then you will be putting the electron into 3d. You will be putting the electron into 3d. So I have shown you the electronic configuration of elements number 11 to 20. Let's see. Sodium 1s2, 1s2, 2s2, 2p6, 3x1. Magnesium 1s2, 2s2, 2p6, 3s2. Aluminium 1s2, 2s2, 2p6, 3x2, 3p1. Silicon, 1s2, 2x2, 2p6, 3x2, 3p2. Phosphorus, 1s2, 2x2, 2p6, 3s2, 3p3. Sulfur, 1s2, 2x2, 2p6, 3x2, 3p4. Chlorine, 1s2, 2x2, 2p6, 3x2, 3p5. Then argon, 1s2, 2x2, 2p6, 3x2, 3p6. Then we have potassium. By the time we fill 3p6, the next we're going to fill is 4s1. So when we fill 4x1, that will be for potassium, 4s1. Then for calcium, it will be 4s2. So this is how we write the electronic configuration of element number 11 to 20. I'll also drop an assignment for you. Try and write the electronic configuration of element number 21 to 30. Now, what do we need to know from this? Given the electronic configuration, examiner can ask you the following question. I've tagged possible questions. Just giving you the electronic configuration of an element, examiners can ask you the atomic number of that element. Examiners can ask you the number of electrons in that element. The examiner can ask you the number of protons in that element. Examiner can ask you the type of ion in that element. Examiner can ask you the valency shell. Examiner can ask you the valency electron. Examiner can ask you the combining power. Examiner can ask you the period in the periodic table. Examiner can ask you the group in the periodic table. Examiner can ask you the number of unpaired electrons. Examiner can ask you the formula, the chemical formula that of the compound form when it combined with another atom. So my next video is going to be very interesting because I will be showing you how you can use the electronic configuration to deduce all of the listed possible questions. So watch out for that video and make sure you subscribe and like our videos so that you'll be notified when the video is out. Don't forget, I have a chemistry calculation textbook that is available in a PDF format that you can download and read on your phone. For you to download it, just go to this website. For you to download it, go to this website, the globaltutors.com.ng. So long, success. See you in my next video class.